looking at what's really valuable, what people are using. Yeah, what's really valuable to the end consumer. So my focus will be to talk about in my I have two talks, right? So in my first talk, I'll focus mostly about cryptocurrency and Bitcoin, the cryptocurrency, crypto economics aspects of it, and the history of Bitcoin, and why how the industry has shaped with time. And in the second talk, I'll focus on some of the cool projects that are coming out from the crypto industry space. I'll not focus too much on the blockchain, the permission blockchain or these private chains that some enterprise is working that no one really uses. I'll focus on projects that actually normal people and everyone is using, and some cool research areas that maybe you can look out at in the crypto industry. Yeah, so let's get started. So the main idea of the main background behind Bitcoin and cryptocurrency is to solve the centralized currency problem. So if you read about the history of Bitcoin, it started in I think first block was mined in 2009, early 2009, but the development started in 2008. And the main goal was to build a decentralized currency, right? That a currency that no one holds, no one has the power to control, basically. So, like, say we have INR or US dollar, that's basically controlled by the government, right? So, um, yeah, so that's basically governed by the government, and they can print as much money as you want, right? It's like, say, and they can do anything. So, and that the reason why people actually hold gold is because gold is limited. And no one uh, uh, has control over gold. So, say if our government decides to print a lot of money, and we have a way to hold on to our savings, hold on to our value, because gold is limited in supply. So that was the main. So the thought process of the initial developers of Bitcoin and the initial people who were getting involved was to solve the centralized currency problem. Um, and we had, yeah. So that was the main thought process. And you can see, like, okay, so this image illustrates the fact that how the value of you have much to don't in order you have got this much amount, and decreasing, and so that you can buy sanitizer or yeah, same with that around that. And the purchasing power of the dollar. So in 2017 only, the value has almost gone to zero, right? In some sense, it's gone to it's decreased by 96% in 2017. And this is going down right now. The Federal Reserve is printing more money due to the financial payout that they are giving out to various businesses. And and yeah, they can essentially, what the government can do is they can government is sort of, we have democracy, but it's still quite centralized, right? So, like, say if someone is close to Donald Trump in US, he can give this payouts to those businesses. Or in India, if someone is close to, say, Modi or the BJP government, they can essentially give that payout to those businesses. Um, yeah, I'm getting a request to start PPD mode, so yeah, I'll just do that as well. But yeah, so no one. How do you solve this problem, right? You have this. You have democracy, but you have still power on printing money. So and government can decide to favor certain individuals and give them these payouts, and they can print as much money as they want. So we were the world was on the gold standard till uh, till the middle of the 19th century or 20th century, or some around that time. And after we got off that gold standard, then it's like, okay, you can there's no there are certain restrictions to how much they can print, but it's still quite up to them to how much money printing they can do. And yeah, so this essentially what people tell you what inflation is, right? Like what monetarists think it is. We have it's Keynesian. We have two economics branch of economics. One is Austrian economics and one is Keynesian economics. And so yeah, they are like, okay, the inflation is better than deflation, and people don't have an idea of what essentially is happening behind the scenes. But it's essentially, in a way, it's theft. Your savings are getting crushed and because of the fact that government has
आवाज बारीक करून टाक तुझा.
hello.
नाही नाही, हे आपलं कसं ते एक सर्टिफिकेट मिळतं हो. त्या सर्टिफिकेटला मान असतो, एक मार्क असतो एनबीए ला.
Can someone
मला
hello?
सगळे थर्ड इयर पण सगळे झाले. थर्ड इयर, फोर्थ इयर, फर्स्ट सेमिस्टर, सेकंड सेमिस्टर झालं.
Yeah, can you Poonam ma'am, can you see who is the one talking and can you mute them?
नाही, लास्ट इयरची फक्त परीक्षा होणार आहे. ऑनलाईन बसायचं आपलं निवांत करत, सबमिशन करायचं, मार्क मिळतात त्यांनी.
Hello. Yeah. So yeah, that essentially what inflation is. And all these things, people have been trying to solve this problem, right? Like there was this cypherpunks community that was basically a mailing list of cryptographers who used to discuss these issues and how to solve these issues. And yeah, we have this concept of fractional reserve banking. And yeah, this video sort of walks through what fractional reserve banking is. And it's essentially, I think everyone has an idea of has heard about this, that banks don't have to hold as much. They need to hold if say they are giving loan of 1 crore rupees, they need to hold like say 10 lakh rupees or something like that. So that's the concept of fractional. Yeah, maybe if say every one of us goes to our respective banks and we withdraw our money, most probably we won't be able to do it. We'll have a bank run, and people, yeah, the banks will essentially need support from the RBI, like the Yes Bank scenario happened recently, right? Like in which they had a limit of I think 50,000 rupees per day. That people could withdraw. That was because many people were withdrawing and the bank didn't have funds. So if everyone goes to their bank account, they can't withdraw their money, and it's essentially just a number that exists in a private network, which is the bank's private network. Of course, banks are regulated by the RBI, and they have to follow certain guidelines, and most of the good banks do follow that. But it's still if it's good to have certain alternatives, right? If the bank if the banking system fails, or if there are certain banks that are not following the guidelines well, people should have an alternative to hold their funds. And yeah, so there is no way to own your own money. So one way is to actually hold cash. That's one way. One another way is to say hold gold. if you really want to hold your own money and you want to have the ability to spend it whenever you want. And but you can hold Bitcoin, right? If that's a good way. You can hold the private key to your Bitcoin, and no one can do anything. You have the power to spend the money, and only you are the owner of that of that of those Bitcoins. And you can easily, so say if you want to go to abroad, right? Like if you want to go to any country, you can what you can do is you can buy Bitcoin, and you can move more money if the government has a restriction, like you can move 10 lakh rupees in cash from India to USA. Then if instead, what if you buy Bitcoin, there is no restriction. It's your own money. It's just a private key, right? It exists everywhere. It exists throughout the universe. Um, so yeah, that's something interesting, right? And we'll get more into it as we progress forward. And yeah, so I think what I'll focus in this. So I was thinking maybe we'll talk about the cryptography aspect of things as well, or some. We'll focus first. I think we might not have enough time to cover the cryptocurrency aspect of only things. So we'll focus on that and focus on Bitcoin white paper and all these problems. And just a side note is that the Bitcoin ecosystem, the crypto ecosystem, has so much research and so many interesting people. And it's not just the Bitcoin white paper or the Ethereum white paper that you see. Even the Bitcoin white paper was work of Satoshi Nakamoto, right? It was work of anonymous person or a group of individuals, but it still didn't mention all these things that have come out from the community. It's all open source work that the community has done. And it doesn't mention various things like, it doesn't mention the 21 million coin cap. It doesn't mention multi signatures. That is a very multi-sig transactions. That's a good way to secure your Bitcoins. It doesn't mention 10-minute block times. There's so many things that are still not part of the white paper, but as you get involved in the community, you somehow learn these things from some, maybe say bitcoin.org website or some other blog or so on. Yeah. So I'll just skip these slides for now. But essentially, the cryptography aspect of things is, I think most of the people are quite technical. So most people understand what are hash functions, how the encryption decryption work, um, what is symmetric encryption and asymmetric encryption. The symmetric encryption, you have to use the same key for encryption and decryption. For asymmetric encryption, we use the concept of public private keys. And yeah, maybe we'll come to this later. But if someone actually wants to read more about the cryptography aspect of things, or go deep down into Bitcoin's protocol, understand Bitcoin scripting language, and stuff like that, I really recommend this book called Mastering Bitcoin. It's written by Andreas Antonopoulos, who is a very he is very famous in the Bitcoin community. He speaks at various conferences, and he has been advocating about Bitcoin since very early. And yeah, he writes. He has a very good YouTube channel as well. You can check that out. But if you really want to understand, he has this Mastering Bitcoin book, which is open source. You can read it on GitHub. All the chapters are in the textual format. You can read that, or you can even buy the book. It's available in hard copy. So yeah. So yeah, I'll just briefly talk about the history of Bitcoin and the some. I'll just walk through the white paper as well. And so before Bitcoin, there was, as I mentioned before as well, there were various attempts at creating this decentralized currency, in which no one has a power, no central person or company has a power over its say monetary supply or has a power to block transactions and so on. And so there was DigiCash, which was a company started by David Shom, and that was started in 1998 during the internet boom, the first internet boom uh, before the crash in 2000. So many people, even PayPal was actually working on. Um, and some what happened in a gist, what happened to most of these projects was that they had some central point of failure. Some of them were not able to solve, say, double spending problem. um, then some of them didn't have a good mining algorithm, how the currency gets in, how the new currency is created, um, and so on and so forth. And even some of them actually got, some of the founders of these companies or of these cryptocurrencies got arrested by the government, because the government doesn't like anyone to create a new currency, right? Like that's uh, if that's really big power that they have, that they don't want to give, is the power of currency to the people, because they can tax people. That's how essentially the governments work, and having their own currency, they can go to wars. They can just print their own money, right? Maybe they can say, okay, we want to go to war with a country, and they can print money and go to war with that country, and that money printed will be just accounted as spending for the war. And for the others, we suffer because the supply of the money increases, right? If say only 100 rupees exist in the world, and I have 1 rupee, then I have 1% of the supply, and that means I have a very large purchasing power. Instead, if the government say prints from 100 to 1,000, now I have 0.1% of the supply, so I don't have that much purchasing power. So that's how things work. So we had DigiCash, then we had PayPal. We have Elon was one. Um, they were also thinking of creating their own bank, creating their own e-money, and they had launched this e-gold operation as well. But all of these, the common theme is again that they essentially either they had a technical flaw or they got shut down by the government, which essentially means they had a technical flaw to an extent, because the goal is that no one can shut you down. That's how the technology of the cryptocurrency should be like. Um, yeah. And we had also BitGold. So Nick Szabo, who many believe is Satoshi Nakamoto, the creator of Bitcoin, he had created BitGold. I highly recommend to just check out his blog. It's called Unenumerated. If you just look Google search Nick Szabo blog, you'll find that he has been writing about this. So he was the one who had came up with his own proof of work system, which Bitcoin's mining process uses. Um, yeah, and uh, he had this project called BitGold, which is quite similar to Bitcoin. And many believe he was Satoshi, but he has a very interesting background in the sense that he has a lawyer. Has background in law. He has background in mathematics. But he was not much of a developer, as in like he was more on research side of things, and that's one of the reasons that BitGold it didn't have that from what I remember, that much of a code base compared to say Bitcoin. Um, yeah, so that, and actually most of you know about smart contracts. So Nick Szabo was the person who uh, invented the concept of smart contracts. So he is quite he has various contributions in the blockchain and the crypto industry. And we also had Hashcash. So Adam Back, who is now the founder of Blockstream, which is a company that hires, which has one of the most numbers of people who were as their employee who are working on Bitcoin's core code base. So he also had worked on Hashcash, and Hashcash is used as a proof of work algorithm in Bitcoin as well. And in fact, I think in the Bitcoin's white paper, there's a reference for Adam Back's Hashcash as well. So yeah, I'll just walk through this. I know this is not that technical, but I think having a history knowledge of the history is really beneficial. You understand why people are building on things. Uh, so there's this site called Satoshi Nakamoto.me in which you can look at various posts that Satoshi wrote. So many believe no one knows who Satoshi Nakamoto is till date. My guess is, and what most people believe is, it might be Hal Finney. He is a cryptographer. He was a developer, and he was the first person that Satoshi sent a transaction to, and he actually had a disease, and he that paralyzed him. So, and when he had this disease and he got paralyzed, that's around the time when Satoshi Nakamoto stopped communicating in various forums, Bitcoin forums. And so many believe it might be Hal Finney, and Hal Finney has died now, so no one really knows. And it's still or some people believe it might actually be a group of people. But in any case, you can go to SatoshiNakamoto.me and you can see various platforms on which Satoshi interacted. So we had this Bitcoin Talk forum in which the Bitcoin community used to come and discuss. It was a Bitcoin focused forum, and you can see all these communications of Satoshi. And we had this SourceForge mailing list in which Satoshi used to. That was the original mailing list of the cypherpunks. Um, so yeah, you can check this out. It's quite interesting. And yeah, this link is the one in which he. So this is November 2008, in which Satoshi dropped the Bitcoin eCash P2P eCash paper, and the paper right now is available on Bitcoin.org site. But essentially, that's what he did, and he posted this as under his name Satoshi Nakamoto. And back then, people were not that they were not. It was just an open source project. That's how it started off, and no one was like, okay, this is Bitcoin. This is so revolutionary. Many people in this cryptographers mailing list actually doubted Bitcoin's technical architecture and so on and so forth. So yeah, that's how it started. Yeah, and some of the early developers that actually contributed to Bitcoin's code were Gavin Andresen and Hal Finney, and they were the ones that extensively communicated with Satoshi over email. And you can add various Bitcoin codes contributors right now on this Bitcoin core website. And Gavin Andresen is still alive. Hal Finney is not alive anymore, but Gavin Andresen is still he's I think part of the MIT Digital Currency Initiative these days. He isn't contributing that much, but still he is quite active on Twitter, and you can have a chat with him if you want. Yeah. So and essentially, Bitcoin. It was not only Satoshi that developed it. Satoshi was just developed in the most of the initial code that was written in C++, and other people downloaded that and they pushed their own commits. You can go to GitHub and you can actually see the history of various commits. And it was an open source initiative, and it was not the work of one person. There were dozens of people involved. Yeah. So yeah, I'll just walk through some of how Bitcoin transactions work. We have this um, in which Bitcoin uses the model. The model is called UTXO, unspent transaction output. Essentially, what happens is how new Bitcoins get generated, and maybe we can look at the white paper as well. I think most of you might have read it already, but still worth going through it once. And so how do new Bitcoins come in supply, right? So what happens is people essentially Bitcoin is it uses proof of work algorithm, and what essentially people are doing is they are trying to generate these new blocks, and they are as they're generating these new blocks, they have to guess a certain number, and that if they guess that number, they'll be able to, and they send that information that okay, we found this hash, and if that, and they communicate it throughout the network, and if most people verify it, then it sort of gets accepted and people start working on the next block. And what the rewarder, the person who mines that block, that person gets Bitcoin, and he can then maybe say use those Bitcoins to buy pizza, or use anything. And that's how essentially new Bitcoins come in supply. Initially the block reward was 50 Bitcoins, and right now it's there was a recent halvening. So I think so it got from 50 to 25 in the first halvening. In the second halvening, it went to 25 to 12.5, and now the third halvening that happened recently, it has gone to 6.25. So it's an infinite GP basically. And if you try to solve this infinite GP, you'll get that if you do essentially the R is 1 by 2. So the formula is A times 1 minus 1 by R. So A times 1 minus 1 by 2, which is half. And if you solve this out, you'll see that you'll get 21 million Bitcoins. And essentially the why 21 comes is because the halvening happens after 210,000 blocks. So that's where the 21 is coming from. And 210,000 blocks multiplied by say 50 plus 210,000 blocks multiplied by 25 plus 210,000 blocks multiplied by 12.5, and so on. If you add that up, that will, you'll get that sum to be 21 million. So that's how new Bitcoins come in supply. And what essentially happens is the person who, say, the miner who gets those Bitcoins, he creates a he creates a new transaction, and that transaction, say I have 50 Bitcoins, a transaction worth 50 Bitcoins, and I want to pay you 1 Bitcoin. So what would happen is I will create a transaction in which I send 49 Bitcoins back to myself and 1 Bitcoin to you. So that's essentially what's happening here. So say if I wanted to send, so here in this example we have, let me go in presentation mode. So we have this. I have this point. I have a transaction output worth 0.1 BTC, and I want to send someone 0.015 BTC. Okay, so what I'll do is I'll send that person 0.015 BTC, and I'll spend the remaining change back to myself. And this amounts to 0.0095 and not zero point 0.1 BTC, and that's because the remaining amount is used to pay the miners, the transaction fees to pay the miners. So the incentive for miners to include your transactions is that they earn these transaction fees, right? That's why, and we have seen certain scenarios in which we get empty blocks. Sometimes what happens is, like, say a block got mined, and a miner who started say we block number 10 got mined, and other people started working on block number 11, right? And they found block 11 very fast. Like they were like, okay, they just hit the number that was required at the first core, for example. So what happens in that scenario is the miners, they just they just send that empty block without looking at the transactions that are pending in the network. They just send that empty block to the others, that okay, we have mined this block. So sometimes we do get empty blocks as well, but the Bitcoin's model is designed in such a way that miners have an incentive to include your transactions. Yeah, so that's how this in the transactions flow that I sort of explained. It's yeah. Um, Proof of work again. I think most of you might know it, but essentially it's one CPU, one vote, and anyone can join a network. They just need to have a computer. Right now, initially people were mining using their CPUs, like say your laptops you have currently. But now the difficulty has increased so much that you can't mine any Bitcoin with your computers. You need to have, we have these mining pools that are dedicated to mining Bitcoins. It's a very large, it's a multi-billion-dollar industry, and most of these mining pools are actually in China. Um, and what we have is they have this they combine computing power. They have very large computers that are just guessing and trying to mine blocks, and they combine this computing power, and they have a chance of mining bitcoins more than a normal person. And essentially, how the if one question is like, okay, how does the um, difficulty actually increase, right? Like um, how has how does the protocol itself compute that uh, to increase the difficulty with time? So how it checks that is within the protocol, there is a it checks that okay, how many blocks are getting mined per hour, or there's certain I don't remember the exact check, but it's you can assume that it checks that how many blocks are getting mined per hour. And if say in 1 minute 10 blocks get mined, right? Like, or in 1 hour we were used to mine the expected number was 10 that should have been mined in 1 hour, but instead of 10 we have 100 blocks that got mined. So what would happen is the protocol thinks, okay, so we have this 100 blocks that are getting mined, so we need to adjust this difficulty uh, back, increase the difficulty so that the uh, the the number comes back to 10, right? The number comes back to 10 blocks per 1 hour. And it's not that the difficulty always increases, it sometimes decreases as well. Like say if instead of 10 blocks getting mined in 1 hour, if say 5 blocks get mined in 1 hour, then the network it essentially sees, okay, the computing power that is in the network is not that high, so we need to reduce the difficulty. So yeah, that's on the difficulty aspect of things. um, and for the node, new transactions are broadcast to all nodes. This is again very basic stuff. Again, about the incentives. The incentive is to get Bitcoin rewards. That's why miners are mining blocks. Um, yeah, and just talking about Bitcoin's privacy model, I think this is also something interesting, right? Like people say that um, Bitcoin and there's some cryptocurrencies that are focused on privacy, right? So people say that Bitcoin is private, or some people say like what the Indian government was saying was, this no one can track it and so on. But Bitcoin's network, the I read a research done by UK's bank, and yeah, and they were essentially they listed down from one to uh, from 20 or something, the mode of transactions used for terrorist financing, right? Like that's what like the Indian government was saying, and various other governments were saying that okay, Bitcoin and these cryptocurrency are used for terrorist financing. Um, but Bitcoin actually was not number one. It was 10th or 11th on the list, and cash was actually quite above on that list. And the reason is Bitcoin is not that private. You can see on the Bitcoin network all the transactions, right? You can see these. You can look at the block. You can say, okay, this you can say okay, this was the transactions. You can look at all the transactions, and you can look at all these addresses. Okay, this address sent this much amount to this address, and so on and so forth. And like say, if you even catch one person on that address, or you catch one IP on that whole chain, right? Like say, I can even show you on this explorer. If you look at this blockchain explorer, you can look at the whole chain, right? Like say, this is how this Bitcoin got generated by the mining pool, and the history of this Bitcoin or this transaction. So even if you catch like one person in the middle or one IP, you can trace everything right from that. So Bitcoin is not that private in that sense. And I just I think this might be a good example as well. So let's look at the recent blocks or transactions. So let's look at this transaction. Um, Yeah, so say you go to this address, you can see all these transactions. Um, I don't remember the exact. I think there was this. They had this graph as well in which they used to show the whole history of the Bitcoin. Not able to find it, but look, you can look that out. Basically, they'll show arrows of the origination to its final destination. So Bitcoin is not that private, right? It's pseudonymous, and what essentially how one actually means a good way that people who to maintain privacy in Bitcoin is to use a new address for each transaction. Like say if I receive some payments in Bitcoin, I use a new address associated with a new private key, and I just keep that Bitcoin there. For another transaction, I should use another address. So that's the recommended way of achieving privacy in Bitcoin, and that is to use new address for each transaction, but it's still not that private compared to other cryptocurrencies. So there's this cryptocurrency called Monero, which if you go to like the dark market, um, if you go to the dark web in which people are buying drugs and stuff like that using the Tor browser, no, initially Bitcoin was getting used there in 2011 or 12, but most of them have actually now shifted to Monero, because in Monero you can't see anything, right? You can't see which address is sending funds to which address, and you can't even see the amount of funds that are getting transferred, right? Like say if you have, I sent my friend 100 Monero coins. Um, no one knows it's just they use some really great cryptography. It's backed by I think the Kryptonite algorithm, um, and no one knows anything. So that's what people are essentially using. And if you want, you definitely should look at Monero. When I was working on my own company, we actually had one person working completely on Monero, and it was really fascinating to see the cryptography that these people have worked on. And another private cryptocurrency is Zcash. So Zcash is pseudo private cryptocurrency, and most people actually don't. If you go to the dark web, or if you go all these gun markets or assassination markets on the top, which I don't recommend, but you can look at them using the Tor browser. And most of them actually use Monero and not Zcash. And about the yeah, so that's essentially the white paper of Bitcoin, and you can see like Adam Back, his Hashcash is mentioned here, and there was some other interesting projects that tried to solve the uh, Bitcoin problem were also mentioned. Um, so this I'll just walk through the coin market cap. So this is the place where all the traders go to and look at various cryptocurrencies. So you can see all these cryptocurrencies, the trading volume, the 24-hour trading volume, what's the price, what's the change in price. Again, this might not be needed technically, but it's good to know because if you are going to develop on the cryptocurrency aspect of things and not like the core blockchain permission chain, it's good to know all these things that are happening. What industry, what are the big players, and so on. So um, yeah, I'll just reload this page. So you'll see the market cap, the total market cap of the crypto industry right now is $255 billion. And this is the BTC dominance, which means the percentage of this $255 billion that belongs to Bitcoin. And that's still 67%. So that's quite high, right? And most of the people, they'll tell you, okay, that Bitcoin is Bitcoin is slow, Bitcoin doesn't have a smart contract language, and so on and so forth. Um, but it still dominates the cryptocurrency market cap because of the word of mouth, because of the network effects, because it's quite decentralized. Most of the other coins, what they have is like some company has started that coin, or some group of individuals that have started that coin. Um, but Bitcoin, it grew organically. It has, I think, in terms of cryptocurrency, uh, if you look at the amount of holders, it has the most uh, distinct holders are actually in Bitcoin. Um, and we have Ethereum, which is at number two. Ethereum, most of the technical people, blockchain are familiar with Ethereum. It's a smart contract platform, and there are some other coins as well. So like I work at Zilliqa, right? So they have their own coin. So you can look at Zilliqa. It's at right now at number 64 in the coin market cap. It has a market cap of $90 million. Um, and yeah, there are some other interesting projects. So if you look at this, the list of projects, the top 100 ones are actually either blockchains. Most of them are their own networks, or they are ERC20 tokens, which are basically they are tokens built on top of Ethereum. So like Bitcoin, Ethereum, they are their own blockchains. XRP is Ripple. It's a centralized type coin. Bitcoin Cash, Bitcoin SV. These are again their own networks. Um, there are not many dApps in the top list. And Monero, as I mentioned, is the privacy coin. That's at number 14 with a market cap of $1 billion. And we have all these coins. Most of them are again blockchains. Maker is an interesting project that's not a blockchain. It's yeah, I'll talk about this more in the second presentation. But this Maker is basically the gateway to decentralized finance in the Ethereum ecosystem. And yeah, this is also an interesting project. So as I've talked about the UTX model, reviewed the Bitcoin white paper, and we have this various types of Bitcoin wallets, right? So essentially, uh, how does one know the ownership of Bitcoin? So what happens is people create a private key, right? And you can create a private key using, say, various solutions. Okay, so there are software wallets, there are web-based wallets, there are cold wallets, hardware wallets, and so on. And I'll just walk through each of them and explain the function of each of them. So software wallets essentially mean wallets that are running on, say, your mobile phone, or say a desktop application and so on. And essentially what happens is the private key gets generated locally. So you don't need to communicate with the Bitcoin network in order to generate the private key. You just need to you can do that locally, right? You cryptographic functions and algorithms, and you can generate that private key. And so for software wallets, we have mobile wallets, like say there is blockchain wallet is one example. Edge wallet is one example, in which people have their private keys on their phone, and they use that to communicate, to send and receive bitcoins. And essentially, what happens is that people generate these private keys offline. And say if I want to receive bitcoins, if I want to receive bitcoins from you, I'll send my address, my wallet address that is derived from the private key to you, and you create a transaction, and you send that in the transaction you mention, okay, I want to send this much amount of Bitcoin to this address, and you then broadcast that transaction to the network. So that's how that works. And in software wallets, we have so there are actually two types of wallets. One is a custodial wallet, and another one is a non-custodial wallet. In a custodial wallet, what happens is there's a central or a party or a third party that is actually holding onto your funds. So they hold onto your private. They don't show you the private key. They are holding your private key, and basically your funds. How they show you your funds is your funds are just a number in the database, basically. And for non-custodial wallets, you actually hold your own private key. And there are advantages to and disadvantages to both of them. Like for non-custodial wallets, it's you hold your own private key, but there's risk in managing your private key. You have to say, you write it down on a piece of paper. What you get worried that what happens if my piece of paper gets lost, right? In fact, more than 20% of bitcoins have been lost due to date, and most of them were actually in the early days, like say people who just mined bitcoins, and they were like, okay, this is not that valuable because back then Bitcoin's price was not that high. So yeah, people just ended up not saving that private key. And you hear these videos in which there was one person like who had a private key on his hard disk, and his girlfriend threw that hard disk in the trash can, and he had bitcoins around $150 million, which and yeah, he just lost that hard disk, right? And that was sad. But and most of the coins were lost in the are such examples of the in which people had mined some bitcoins in the early days, but they didn't care to hold on to the private keys. But even till now, people actually lose their private keys, right? Like, say, if you lose your paper, or if someone sees your paper, then they can actually spend your funds. So that's the disadvantage of non-custodial wallets, that you have to manage your own private key. But if you manage your private key, then that's if you can manage it, if you have some type of interesting solution to manage that private key, then that's the way to go. That's how Bitcoin was intended to be used, because we don't want these third parties or centralized companies to hold on to your funds, as is the case with custodial wallets. And we also have these hardware wallets, like so. There's these two companies called Ledger and Trezor. So what these hardware wallets essentially do is um, they they are say a small computer that is disconnected from the outside world. So they store your private key information in a secure chip that never communicates with to the outside world. And if you have to do a transaction, what you do is you um, connect your hardware wallet with your computer, and you send a request to that private key in a way that, okay, I want to send, say, 10 bitcoins to someone, and you sign. The private key is just used for signing the transaction, and the data, that the signed data, is then pushed to the blockchain through your computer. So the hardware wallet itself doesn't communicate. It just signs the transaction. You can and it has a very simple user interface. So say if I requested to do 10 bitcoins, then it will come on the hardware wallet screen that 10 bitcoins is requested. You have an option to decline or accept. If you do accept, the private key that is stored in the secure enclave of the hardware wallet, that signs the message, and the your computer then sends that message, the transaction data, to the blockchain. So most of the people that have substantial amount of cryptocurrency, like, say, $150,000 or $500,000, $1 million worth of cryptocurrency, they own their hardware wallet. Because, like, say, if you are holding, you have your wallet in your phone. What happens if your phone gets lost, right? What happens if your phone gets hacked? The phone is always connected to the internet. You might not know what data other apps are looking at. So that's why hardware wallets are secure. They are disconnected from the internet, and you just use them to, whenever you want to do a transaction, you connect them to a laptop and use them to sign a transaction. So yeah, that's how that works. And yeah, there's this concept of uh, concept of BIP39 mnemonic words. So I'll just walk through this as well briefly. So, private keys are not that simple to remember. So, um, so this is an example of a BIP39 mnemonic. So, what is a BIP, right? So this is again an interesting topic that we can look at. So BIP stands for Bitcoin Improvement Proposal. Um, So what essentially happens is, people have these submit these Bitcoin improvement proposals. These are again all open source. That, okay, say if you want to improve something about the Bitcoin protocol, or something related to, say, Bitcoin's private key, how private keys and stuff like that, you can submit a BIP, and if the community accepts that BIP, then that gets accepted by everyone. So you can look at these BIPs like BIP 1, 2, 8, and so on. And BIP 39 is like mentioned here. And it's like, say, BIP 1 was last edited 7 years ago, in 2013. Um, and there are so many of these BIPs that people submit. So if you're a researcher, you can definitely look. What you can do is you can look at these BIPs. You can see that which BIPs are currently active that people are working on, and you can contribute code to that. You can contribute research to that, and that's all open source. People are willing to work with anyone anywhere in the world. Um, so for specifically coming back to BIP 39, so what BIP 39 did was, it was just, so private keys. If you look at a private key, right? I'll just show you a private key. So this is a private key. I'm sure this doesn't look that good, right? Like, uh, you can't remember this private key. It's not that easy to type, and you can't remember this at all. I for sure can't remember this very big number. Um, so this was a problem that existed. Like, say, if you wanted to use a wallet, if you wanted uh, to change a wallet, if, say, you were using mobile wallet, now you want to go to another, you want to move to, say, a web wallet, you need to import your private key. And how do you do that, right? You can't remember it, and typing this is very difficult. Like say if I have to go from this to my phone, there's a private key written on my desktop wallet. I need to enter it on my mobile wallet. It's not that easy, right? So what was this BIP39, in which essentially what happens is we have these mnemonic phrases, and when someone is they create a new wallet, a BIP39 wallet, they get this 12-word sentence. These 12 words are chosen from a very large word set. I don't remember the exact number, but I think it was 1024 words. So each of this, so they are like 1024, 1023, and so on. So it's a very, very big number, 1024 P12 or something like that, right? Um, that's the possibility of that number. um, and people have to choose the when someone creates a wallet, they generate this they have this random selection of words that get selected from that initial word set. And what happens is from this word set, we generate the private keys. So, like say we have this diagram, we have the seed, which is like the state, the mnemonic. Then we create these private key. We create the from these from this BIP39 mnemonic. We apply some algorithm to it. We apply some function to it, and we get a new private key. And the advantage of this is there's another advantage to this, which is like if you want to hold on to you have 50 cryptocurrency that you want to hold on to. So one example is one way you can do that is you can write 50 different private keys, and you can you need to import that. You need to write those 50, maintain those list of 50 different private keys. That's not that convenient. So what you can do is using BIP39. um, you have this concept of derivation paths. You can what you have is a master. You have this 12 word is the master key, and from those you apply algorithms and you apply certain derivation paths. You generate private keys of other various cryptocurrencies. So for say Monero, you use derivation path number 20, and you generate private key of Monero from this 12 word. And for Bitcoin, say you path number 1, and you apply a Bitcoin's function or whatever, you generate Bitcoin's private key. So that's another advantage of this. And the second advantage is obviously that this is much easier to remember. And even if you don't want to remember it, it's much easier to write on a piece of paper. With the private key, you might miss a word, right? Like if you say in between you miss this 3 somehow, you miss this 3 out, then your um, and these are very large prime numbers, right? So, but in these seed phrases, what these are just 12 words written down, so you can easily see um, that yeah, you can easily write them down on a piece of paper, and the chances of making a mistake are less. Uh, and it's very easy to type. Say, if I had a desktop wallet with these words and I wanted to move to a mobile wallet, then I can just keep. It's very easy for me to type these words out. So yeah, that's essentially what I had to cover for my first presentation. Um, and I'll just talk about some of the myths that you might have heard about, which I think are essential to talk, and which like the Indian in what I've seen is so. I used to run a podcast YouTube channel in which I used to interview various founders in the space, and so I've interacted in the crypto industry with people throughout the globe. And the Indian media, they have, I don't know what, they are quite anti-technology in various terms. Like I remember when Flipkart was coming out, Indian government also, they had some really shitty regulations, and essentially Flipkart had to register in Singapore, and the Indian media and the overall acceptance was not that great, even for e-commerce or for any new technology. And you definitely need to be aware of the pitfalls of any technology. But if you just start blaming without having making any logical arguments, um, it doesn't make any sense. So in the Indian media, people were like, okay, crypto industry, cryptocurrency is banned, cryptocurrency is bad, cryptocurrency is used for bad things and stuff like that, which I'll say definitely say they are used for all these things. But there are various advantages to them. So a couple of advantages. So one advantage with cryptocurrency is uh, you can become your own bank if you fear that, say you are anti-government, right? Like, say you are an activist. How do you can't have you don't have an access to the banking system. You always have the risk that banks might actually close your um, close down your bank account. So initially, like WikiLeaks, for example, if you go to the WikiLeaks website and you look at the donation page, WikiLeaks were one of the first companies to accept Bitcoin. And even till now, I think they accept Bitcoin and so many of these other cryptocurrencies because no, they always have this risk that banks will essentially shut them down. So I'm just looking at their donation page. You can see that they have this Bitcoin address, Bitcoin Cash. They accept Litecoin. They accept Zcash, Monero, Ethereum. All these various donation methods. So that's number one. You become your own bank. You don't need to worry about having a bank or a government to be that can confiscate your funds. Second is as I mentioned, it's a security against inflation. Like, say uh, if there is hyperinflation that has happened in Venezuela, right, or Zimbabwe. So if those people had, say, bought onto Bitcoin, in their savings would not have gone to zero. Their savings, even though Bitcoin is quite volatile, their savings would still have been, say, half or maybe halved, or I don't know, maybe 10% or 20% if they had hold on to Bitcoin. But instead of that, if you're holding on to your government's currency, which is, say, increasing, they are printing a lot of money, um, then you don't have any option. So Bitcoin provides that. So it's a hedge against inflation. Um, and yeah, another thing is you can easily send that to do global transactions. You don't need to go through a bank. So uh, like, if, say, I want to send a transaction to US or Europe, I can easily use cryptocurrency. So Bitcoin is slightly expensive, but I can use some other cryptocurrency which doesn't have a higher transaction fees. That's point number three. And point number four would be, uh, some people don't have access to banks. People who are poor, or people who or people who are in countries that don't have good banking infrastructure, they somehow are not able to participate in the global economy. So with cryptocurrency, they can actually in the global economy. um, and they can say, if someone is working in Venezuela, right, and they are working as a developer, they can accept money in cryptocurrency. Or, say, someone is in Africa in which they don't have a good banking infrastructure, you can use cryptocurrency for accepting payments, throughout the globe. So that's one. And just coming back to the Indian media and um, the lies, so to speak, they perpetuate is, um, yeah, the lie was that cryptocurrency was banned, right? Like, what had happened was, if you the RBI in 2000 or late 2017 or early 2018 had essentially not banned cryptocurrency. The cryptocurrency was never banned in India. What had happened was, there was a ban on banks. There was a law that said that banks shouldn't give a bank account to any business that is dealing in cryptocurrency. So most of the Indian companies, essentially, that were working in crypto, they couldn't get a bank account. Most of them were they got registered in Singapore or Malta or Estonia, all these crypto-friendly places. The ban sort of speech that we had was the RBI had said that you can't give a bank account. That was it, and that ban also recently got lifted out. So now again, cryptocurrency companies are eligible for bank accounts, and we have various exchanges that you can go and buy cryptocurrency. So in India, that you can go and buy cryptocurrency. There is BitBNS that you can look at, that you can buy cryptocurrency. There's CoinDCX that you can buy cryptocurrency. If you're just interested, you can link your bank account and you can just start buy some amount of cryptocurrency from here. It's very simple. Um, and so on. And one more point that I'd like to cover is the point that people say that cryptocurrency is quite volatile. You know that uh, yeah, it's quite volatile. That's an argument. So what we feel in the crypto industry is that one Bitcoin is one Bitcoin, right? Like one Bitcoin is always going to be one Bitcoin. So it's not volatile in that way. Right now, the crypto market cap is $260 billion, which is quite small. So gold's market cap is around $8 trillion. So, so the reason it's volatile is because it's small. If the market cap increased by, say, it went up to till gold's size, it won't be that volatile. So if, say, right now someone buys $100 million worth of Bitcoin, since the market cap isn't that big, we get this in wild fluctuations in price. But if the market cap increases and if the adoption of Bitcoin continues to increase, the volatility will decrease. So that's as simple as that. Um, and in fact, there are some stable coins, there are some cryptocurrencies that are back to $1, right? So for example, when I did my internship in a German company, what I used was I used to accept payments in Tether. So this Tether, I don't recommend. In fact, recommend to use at the value of these coins. So if you look at the Tether and if you look at the price, it's $0.99, right? And I'll just show you another stable coin. So if you look at this USD coin, this is run by a company called Circle, which is backed by Goldman Sachs, and Coinbase also is I think an investor. Um, so I would actually recommend this one. So if you look at this, the value is again $0.99, right? So it's almost $1. If you look at yeah, this coin Paxos, again $0.99. So stable coins, you can, if say you receive payment in Bitcoin, you go to an exchange, you trade the stable coin, that Bitcoin to the stable coin, and then the value of this stable coin will always be one. So and this the like how it remains $1 is like for these centralized stable coins, the company, say for Circles, like the Goldman Sachs company, they claim that they have this much amount of dollars in their bank accounts. So essentially, it's just it's a cryptocurrency in a sense that it's it's an ERC20 token. It's a token built on top of Ethereum, and you can trade it very easily on exchanges. So that's the use of it. So you can't trade Bitcoin that easily with something that is on a bank account, right? You can trade very easily within the blockchain. So this is an ERC20 token. Most of them are ERC20 tokens, which are basically Ethereum tokens, and the value of them is always $1. So people say, okay, it's volatile. I don't want to accept payments in crypto or and stuff like that. But you can in fact accept payment in these stable coins, or you can accept payments in Bitcoin, and you can go to an exchange. It's very simple process. You can convert it to a stable coin, and you can just store that value in that stable coin. Um, also something that people do, and in fact, this trend is increasing quite as well, because most of the currencies. So what people as well are doing right now is like, if I know people who are buying USD coin or these stable coins, because the value of various currencies right now of various countries is falling in comparison to dollar. So people are buying dollar through exchanges, through essentially the stable coin, right? They are just holding on to the stable coin, and that the value of this always remains to $1. And yeah, they are if they are beating out the decrease in value of their local currency. So yeah, that's also something interesting. And there is this coin called DAI, yeah, multi-collateral DAI. This is a decentralized stablecoin. So it has a very interesting mechanism, which I highly recommend to read about. DAI, DAI, and Maker, Maker, which is the company behind this DAI, and which actually is they have this the Maker token is used to stabilize the value of this DAI to $1. So you can in fact keep your coins in DAI as well. But I personally would recommend USDC, because it's yeah, it's Goldman Sachs and a couple of banks, they are behind that, and they in fact have they do audits and stuff like that, so they have the US dollar in the bank account. Some stable coins claim that they have US dollar, but they don't have the US dollar in their bank account. So yeah, that's about it. I think about the cryptocurrency industry. In the next talk, we'll talk about some of the interesting applications, some of these projects. We'll look at them. What's interesting happening in the crypto industry in terms of like research or company startups that are coming out, um, and stuff like that. So yeah, if you have any questions, hopefully you can ask them right now. And I'll just stop sharing my screen. If you have any questions, I'm looking at the chat. Maybe you can. Hello. Yeah. Okay. So I'm just reading the question. Sorry. Okay. Okay. Let's see. What if when the more than one mine the block at the same time? Okay. So the one question is, what if when more than one miners mine the block at the same time? So this happens quite a lot, right? So say if you have two miners that mine a block, what would happen is, so this is concept of the true chain in Bitcoin. The if I mine a block, and if say Poonam ma'am mines a, and if say other blocks that get mined, so like say I was on block number, I mined block 5, Poonam ma'am also mined block 5, then and and we both propagated that, right? We both satisfied the criteria of the hash that was to be mined. Maybe it was different hashes, but it satisfied the criteria. um, and what would happen, what would happen in this scenario? So everyone can see, okay, maybe I mined this block, and Poonam, and both of us are correct. But people, for the next block that is going to be, you have a choice to either build on top of continue block mined by Poonam ma'am, build the chain on top of that, or build the chain on top of my block, right? So that's you have this option. So say if you decide to build the chain, if Poonam ma'am's chain had block 5, it then got mine block number 6, block number 7, and my only had block number 5, right? So and was say, and people were not able to mine another block on my chain. For some reason, maybe Poonam ma'am is more popular, so you're like, okay, I will mine a block on chain. So for the next miner that is joining, his incentive, he wants the correct chain is the longest chain, right? So he'll have an incentive. He was like, he'll look at, okay, we have these two chains. One is still block number 7, one is still block number 5. So he like, okay, why should I mine on top of the smaller chain? He has an incentive to mine on top of the longer chain, right? Because he is spending this computation power, and if say he mines on top of my chain, his value is might get wasted, right? He chain is now at block number 8, and then people are continuing to build on top of it. So the effort of this miner actually gets wasted. So what essentially happens is, with time, there emerges one chain that is the longest. And usually when this doesn't go on till, say, I would say not more than 1 or 2 blocks, right? Maybe it was like, okay, there was one chain that was at block 7, there was block 5. There was, say, two chains that we had at block number 5, then one got at block number 6. One the miner added block number 6 to one chain, then that's it. The other miner would most probably add a block to the chain that had block number 6. So yeah, that's how that works. So yeah, let me see how many questions. Oh, there are quite a lot of questions. Um,
Good afternoon, sir.
yeah. So question is, if we can change address, how transaction balance can be validated? Um, I don't, yeah, it doesn't make a lot